Alright, today we're going to take a look at section 6-1, Graphing Systems of Equations. So, let's go ahead and get started here. Let me minimize myself. So, graphing systems of equations. Let's first look at these 5 vocab words. It would be a good idea to write these 5 vocab words down, and then we'll throw some definitions at you here. Okay, so here are those definitions. A set of equations with the same variables is called a system of equations. This is something like two different equations that both use x and y. That would be a set of equations. We're going to look at those today. What we're going to be doing is we're going to stick them on a graph and see how many solutions they have in common. They could have one, meaning they cross, like an x. They could have infinitely many if they overlap, or they could have no solution if they're parallel and they never cross. So we're going to look at those scenarios today. Okay, we have 4 other words here: consistent, independent, dependent, and inconsistent. So let's start with the consistent ones. If we said that a system of equations, or 2 lines, if we said that they're consistent, what that means is that they have one or more solutions. That means the lines cross, or they overlap. One or more solutions. When we say solution, when we say solution, we mean a point in common. I'm going to write that in pink. A solution means that they have a point, well, we should probably write a little smaller than that, huh? Have a point in common. I'm going to shorten that up. I'm going to bring that over here, and now let's make that pink also. That might be hard to see. How about purple? Okay. Move that over just a smidge. Okay. So when we say that it has a solution, what we're saying is that it has a point in common, or more than one. So, well, there's a difference then. Does it have one, or does it have more than one? If it has one solution, check this out, the green and the blue lines cross. If it has one solution, the system is called independent. If they overlap, if the 2 lines overlap and there's an infinite number of solutions, this system is called dependent. The last scenario is if the 2 lines never cross, then they have no solutions. We would be asking, where's the solution? Where do these overlap? We would say never. So this system is inconsistent. Okay, so those are our 5 vocab words. Let's get started on some examples and what this would look like. So we talked about if there is one solution, this would be consistent, and independent because there's only one solution. If the 2 lines actually overlap, it's consistent because there's something in common, and dependent because they're all in common. Infinitely many solutions, it would be dependent. The last scenario is if they're parallel, they never cross. This system is called inconsistent because there's no solution. There's no place where the lines overlap. Your job today is to graph lines and tell us about this. Are they consistent or inconsistent? And if they are consistent, do they have one solution? Is it independent? Or do they have more than one, or infinitely many, which would be dependent? Okay, someone asked in class, well, could there be 2 solutions? If that was the case, it wouldn't be a straight line, right? You'd have to loop back around. It wouldn't be a straight line. So you'll only be dealing with these 3 scenarios today. Let's take a look here at this example. So, let me move myself. So it says here, use the graph to determine whether the system is consistent or inconsistent, and if it is independent or dependent. So graphing these 2, it's kind of nice, the graph is already done. When we graph these, it looks like they're never going to overlap, right? It looks like they're parallel. Just to check, Yep, look at this. Same slope, -1 for both. So since they have the same slope, they're never going to cross. We say inconsistent, and there is no solution. Done. Let's look at the next one. How about this one? We need to graph these, so we would use our slope and our intercept to graph. So for this one, I would start at -3, use our slope of 1 to go up 1 over 1, up 1 over 1, and so on. This one would have our slope of -1 and our intercept of +1, so I would go up 1, and then our slope of -1, down and over, down and over, down and over, to graph these lines. Once you have them graphed, let's label this. It looks like there is one solution, so we say that it is consistent. And to identify only one solution, we would say it is independent. Again, if it overlapped and they were all over, every line was the same for both of them, if every point was on both lines, we would say that it is dependent. But in this case, it only crosses once, so we say independent. Let's do one for you. Let's do an example here. Try this. So read this question, pause right here, and see what you can do. I'm going to work through this now. So it says use the graph to determine whether the system is consistent or inconsistent, and if it's independent or dependent. Okay. I'm going to do my work here a little bit. I think for this one, let's take a minute. X minus 1, so we're dealing with this one, and then 2y plus 3x. So it looks like we're not really dealing with this equation. We're not really dealing with this one. They're only asking about these two lines, this one and this one. And it looks like they cross right here. So since they cross right there, we would say that it is consistent because there is a solution, and it's independent because there's only one solution. Okay, let's do another one. Pause right here, see what you can do, and then hit play when you want to check your answer. When I worked through this one, I noticed that they're not asking about this line, and they're only asking about these two. And to me, those look parallel, but just to check, let's look at our slopes. Yup, 1 and 1. Since they are parallel, they never cross, so there's no solution. This would be considered inconsistent. So that goes for this one. Yeah, B. That's our answer. I'm actually going to erase that because I want to keep this slide for next year. So let's look at this one here. So this says graph the system of equations, then determine if it's same. So we're really dealing with the same thing. No solution, one solution, or infinitely many. They're using a little bit different terminology, but no solution would be inconsistent. One or many would be consistent. So all we're doing is we're just labeling this. Okay, I had to work through this one here. It says 8x minus 4y equals -12. I can't graph that. I can graph it once I rearrange it though. So I said, let's get y on a side by itself. So I first subtracted 8x from both sides. I didn't show that step, but I subtracted 8x from both sides, so I ended up with -4y equals -8x minus 12. When I did that, I ended up getting this as my answer, y equals 2x plus 3. When I graphed those, they're the same line. So since they are the same line, there are infinitely many solutions, and we could also consider this if they were asking, not that they are, but if they are asking, we would say that this is consistent and dependent. What was it? I think it was an E. Okay, so that would be our answer for this if it was asking for this terminology, but they told us to choose one of these. Let's look at another one. Same deal. So I had to graph these, but in order to graph them, I needed to get these into slope-intercept form. I can't graph them when they look like this. So when I got them into slope-intercept form, here's my work. Let me know if you have questions. When I did that, I had the same slopes, so there was no solution. If this was asking, I would use the terminology that we just learned, consistent. So it would be inconsistent for this one. Let's look at one that you try. So pause right here, see what you can do. When I worked through this one, these are nicely in slope-intercept form, so I would use this one. I would go up 3, and then use our slope up 2 over 1, so we end up with this line. This one also has an intercept of up 3, and then it has a different slope. We go up 1 over 2, up 1 over 2 for our slope. And it looks like it does cross in one spot, so I would call this consistent and independent. Independent. Consistent and independent, if they were asking. But instead they asked for the solution. So we said one solution because it crosses once. And the solution is at 0, 3. So we would say over nothing, up 3. That would be where the solution is located. This is another one. You can pause right here, see what you can do, and then hit play when you're ready. When I worked through it, this was the work that I did, so check that out. Let me know if you have questions. And I said that it would have no solution, so I chose no solution because they don't cross. Let's look at this example. So Naresh rode 20 miles last week, 35 miles this week, per week after that. Diego, 50 miles last week, 25 miles per week after that. So our job is to write a system of equations and graph it. So here's how the book chose to write those equations. So we did 35 miles per week times the number of weeks plus the number that was already done in week 1. So Diego, 25 per week plus 50 to start out with. When those are graphed, it looks like they cross at one section, one point right here. So this would be considered consistent and independent. And it says here they appear to graph at this point right here. So what would this be? Week 3, they ride 125 miles total, or that they would have ridden 125 miles in week 3. They will have ridden the same number of miles. If this is how we're solving this, you have to be careful graphing. So be very careful. Use a ruler, use graph paper, and be cautious with it. Be careful. Precise. All right, Alex and Amber. So they're both saving money for summer vacation. So Alex already saved 100, but plans to save 25 per week. Amber has already saved 75, but plans to save 30 per week. So if you're going to pause right here, see what you can do. See which one your choice is, and then hit play when you're ready to compare with me. When I did it, I worked through these equations. I know they're written here, but this was my thought process was 25 per week, but already saved 100, 30 per week, and already saved 75. When you graph these, just be very precise with it. The smaller your graph is, the less precise it will be. And use pencil, draw fine points and all that. So it looks like at week 5 they would save this much money, so it's between 200 and 250. I guess they're not asking, so we would just say at week 5 is when they save the same amount. So let's go ahead and take a look at homework for this section. Here are your practice problems. Please let me know if you have questions. Email me anytime.